Okay, good morning, good afternoon, good evening, everyone. This is the Security Area Advisory Group, SAAG. We're going to get started. I think some folks are going to start filtering in. Welcome. My name is Roman Danilou. I am one of the Security Area Directors, and up in front of you in the room is our other new Security Area Director. Welcome, Paul. Want to say hello?
Hello.
Well, it's later in the week, but I do want to remind everyone that the note well still absolutely kind of applies, and this reminds you of your responsibilities in participating in the IETF. But really, to put a finer point on it, I would just like to emphasize to everyone, we all have to live the IETF Code of Conduct, and the idea here is we really need to make sure that when we interact with each other, we keep things professional, we're respectful to our colleagues, we focus on the technology, and overall remember, we're all pushing to make sure that the internet is a safe place. This is the security area, kind of after all, and we're working to connect everyone around the world. Agenda-wise, we have a few administrative things as always to get a summary of what's happening in the area in the working group reports. Continuing our tradition of deep diving into technology we've been developing for quite some time in the area to make sure everyone understands it, given its pervasive deployment. Paul graciously has agreed to give an intro to Ipsec, and then we have quite a lot of time to talk about other business if folks want to come to the open mic. I'm going to pause here, despite having a lot of coffee, to ask if anyone wants to bash the agenda. Okay, I am not seeing anyone. Is that someone coming up to the mic? I can't tell. The box is too small. No. Okay, perfect. So in that case, let's keep going. We have a number of working group summaries coming in. We won't talk about the working groups that sent a report. You can either go to SAAG to see the ones that were sent, or we'll see kind of links. If anyone wants to proactively start queuing up for working groups to give a heads up, please by all means kind of do it. So ACE sent a report. Acme sent a report. COSI did not. Does anyone want to say something here? I think Mike's coming up to the mic.
Mike Jones, Microsoft. We met on Monday. A number of drafts were presented with requests for working group reviews. And we are very, very close to taking the original COSI specs from draft standard to standard, as reported by Evo. And I'm a new chair. Where do I send the report?
Please just send it to the SAAG list.
Okay, thank you very much.
Much appreciated. EMU sent a report. Lake is fine. MLS also. Does Hannes, Rifat, or anyone from the working group want to talk about the first OAuth session that happened earlier in the week? There's also one happening later today. Okay, if you do, you can queue up later. And anything from OHI? Richard, Siobhan, working group? OpenPGP is good. Anything from Privacy Pass? Ben, Joe?
This is Joe. We're going to meet later this afternoon. We have a couple agenda items. Most notably, we've kind of reworked our architecture draft a bit to kind of accommodate different use cases.
Thanks, Joe. That's an editorial mistake. We should have given you a pass since you haven't met yet. Rats had a session, had two sessions already. Nancy, Ned, Kathleen, anything? Okay, sec dispatch center report. So we got a plan for 4 different things. Suit center report. We're good on TEEP. Anything from TLS? Sean?
Hello. So, yeah, many of
Morning.
our drafts are on our way. We are trying not to relitigate the YECH question, but we will continue to debate that as we can progress. So, thanks.
Thanks, Sean. Okay, so we have a number of working groups meeting later this week. You can see them there. Some have already proactively sent a report. If any of the chairs or someone from those working groups wants to come up to have any words, by all means, kind of do that. We'll also jump to the working groups that are not meeting, if anyone wants to make a comment about those. And then lastly, we'll just call anyone else that wants to comment on what's happening in related non-sec area working groups or outside the security area, but relevant to sec. So pausing here for commentary.
Hi, Justin Richer. The HTTP working group has made significant progress on both HTTP signatures and HTTP digests in recent months. And I would encourage people in the sec area to go take a look at both of those 2 specs. They are things that kind of bridge the apps and sec areas. So even though they are hosted in HTTP, it's going to be of interest to a lot of folks here too. And we'd appreciate the eyes. Thank you.
Thanks, Justin.
And this is Barry Leba talking about DMARC. We did not meet here. We're going to have an interim at some point soon. We're working on the proposed standard version of the former experimental spec and are currently debating what the text is to get rid of the public suffix list usage and use a tree walk instead. And that's causing a bit of controversy in the working group, but it's resolving. So that's where we are.
Thanks, Barry.
Hey, Tim Capelli, Microsoft. And W3C, just something to be aware of, there is an effort going on to redefine how authentication works in the browser, essentially bringing the browser into a more active role in things like OAuth and OpenID Connect. It's a significant shift, obviously. So it's just something to be aware of. There is a community group that I'm a co-chair of called the Federated ID Community Group, where one of the proposals is kind of sitting because it doesn't have a home, and that is open to anyone to join because it's a community group. So if you're interested, it's a very contentious topic, as you might imagine. So,
Thank you. All right, I'm not seeing anyone in the virtual queue. My eyes might not be sharp enough to see the video. Paul, are we clear on the back mic there? In person? Okay, yes, I think so. All right, thank you. So the other thing I would add to things happening outside the IETF, we've mentioned in a couple of working groups. We had a talk on it at a previous IETF. The NIST round 3 PQC decision should be coming real soon now. So I think we are all impatiently waiting for the results, and that'll probably trigger quite a lot of work inside the IETF. Okay, moving along. So that was the commentary on the working groups. Agenda-wise, we are now seamlessly moving into the AD portion of this, and we have a lot of material here. The motivation is that over the course of time from the last meeting, the ADs get all sorts of questions about what's happening in the SEC area. We're just trying to be as transparent as possible. So we summarized all the different inbound requests that we get on I don't want to say on a regular basis, but things we commonly get between meetings, and want to put it out here to the community. Paul and Ben, please kind of jump in here, kind of heckle me, or kind of make additional commentary as we get through all of this. All right, so there's, in addition to all the different working group documents, we of course are sponsoring we are also personally sponsoring kind of a few documents. We published the ERS kind of update as RFC 9169, and then we have security.txt and the updated code points for XML sec in the RFC EDQ. Active still is the numeric ID sec considerations, and from sec dispatch, we identified that we're now sponsoring those registry changes for our SSH. We have not, Paul and I have not yet talked about who's going to grab that one since that just came out on Tuesday. Ben or Paul, do you want to have any last words on, I guess, on the numeric considerations draft, since that's still in flight?
So I don't yet. I just inherited this document obviously from Ben, so maybe Ben has some comments he wants to make.
Yeah, I think the audio is live now. So for that one, I believe the waiting for write-up state means that it finished the IETF last call, but the comments maybe haven't been addressed. And so the write-up of the waiting for write-up is the ISG ballot. And I believe that this one, there was some controversy about whether or not changes were needed to the document. And I was of the opinion that some changes were needed, but it was not easy to precisely characterize what those changes were. And so it's been sort of in a holding pattern while the author and I tried to get some agreement about what the changes that actually were needed were. And so I don't know if there's a clear plan for getting that to happen, but I may have some more cycles to think about it now that I'm not in the day-to-day grind of reading a bunch of documents every week.
Wow, you make the job sound so appealing, Ben. And by the way, technically you continue to stay AD until the end of SAG. So if you'd like, you're happy to keep the video kind of on with us because you have as much commentary on all this material as the rest of us do. Okay, so moving along, this is just a list of URLs we wanted to just continue to kind of remind everyone in the course of that grind to review the documents, because that is certainly how it feels sometimes in preparation for the telechat. Historically, Ben and I, and Paul will be adding kind of his own, we find things, honestly, we see a lot. We wish we did not see a lot. And we just want to make sure kind of in advance folks understand what are common things that we will drop discusses on. So if you have questions, your colleagues are asking, what should I do to make sure the security review goes okay? Or frankly, you're pushing a document forward is how do I make sure that, that things aren't discussed on? Please do consult that list and share that with your colleagues. We often always get questions of, well, I see what's happening in the working group, but what are the ADs doing? If you want a real-time view into what our queue is and what everything, kind of the disposition of all those things, you can directly click those URLs and get insight into all of that. Ben and I also use the history field of the data tracker. And so if you can look at the states kind of describe where we are in the process, but if you want additional information, for example, what does it mean to say revised ID needed? Like, what do I revise for? Very often you'll find those details in that history field. And then lastly, we're trying to keep that wiki page about the security area up to date, especially to help guide new work inbounding into the IETF and to acknowledge when it's been caught, but perhaps not in a working group yet. So if folks from the outside are looking, we can provide them a summary of what's happening. So that's a link if you get questions for your colleagues about what's going on there, or you yourself kind of want to know, what have the ADs caught, you can find a pointer there. So working group changes since the last time we got together. We in the IETF had an interim BOF, something that we don't do very often, on the topic of sharing credentials, which was called Secret. It was sponsored out of the art area. For folks that attended it, there was some back and forth about where this will ultimately be housed. The decision was this is going to be one of those just like SCIM, which is it's going to stay in art, but overseen by a SEC AD, probably me. So in terms of kind of tracking SEC area works, this is in that post-BOF phase where it looks like there's a lot of interest in a working group. We have a charter, but the mechanics of that have not started. We spun up the PPM working group out of the Priv BOF that happened last time in IETF 112. They're meeting tomorrow. Kernel closed, and in active recharting right now is RATS. I'll kind of pause here. Ben or Paul, do you want to comment on any of those mechanics? So the one thing I'd just like to say about kind of PPM, I mean, this really is a recurring kind of pointer. It is possible to spin up a working group between, in one meeting cycle where you do a BOF and you can have a working group before the next thing starts if there's a lot of different prep work. So kudos to the PPM kind of proponents to having a lot of things kind of teed up in advance and for having a great community discussion to get us here. Wanted to acknowledge some of the changes we've had amongst our working group kind of chairs. So in dance, of course, Paul is up in front of the room, so he could not continue on as working group chair. Congratulations and thank you to Joey for stepping up there. Thank you, Robbie, for your kind of service there in Kitten. In PPM, Ben and Sam, thanks for getting us kind of spun up and getting the work started. And in Skim, Aaron, thank you for kind of stepping in to round out our team. It was just Nancy there alone. And editorially, we also kind of forgot Mike Jones. Thank you for kind of joining the COSE team. Overall, we put out calls, I think, every time between meeting cycles, certainly at least kind of twice a year. If you have interest in becoming a working group chair, by all means, kind of please send us an email. We do keep a running list. As there are opportunities, we do consult that list between kind of interest, skill set, and what we think that working group needs. And I'll also just have, again, kind of a shout out. Thank you, Joey and Aaron. You guys are new time chairs. We really appreciate you stepping into this role for the first time. We've gotten a couple of kind of questions on this one. With any AD turnover, there's a reshuffling of working groups. We want to make sure that the skill sets of the ADs are right, the needs of the working groups are kind of satisfied, and there's appropriate kind of load balancing. So this is the split between Paul and me. What you see in red is where it wasn't a straight swap. So we started from Paul taking all of Ben's working groups. I kept the working groups I had, and then we did a little exchange. Primarily, I'm taking Ipsec ME and OpenPGP because that's an area where Paul is active. Paul had also been doing a bunch of work in dance, and he got EMU honestly just for a little load balancing. We are not super great about sharing new working group lists that we create, so we're going to be better about that. So just wanted to call out that a couple of weeks ago we made SCIT, which is mainly focused on supply chain integrity issues. You can get more details about that from the proceedings. We just talked about that at the dispatch session on Tuesday. The new item we want to talk a bit more about is we need community help on errata processing. If you go to the Errata site, you'll see that there's about 250 reported errata for sec work. So reported is a precise label, which means that someone has filed that errata and nothing has been done with it. So these are unadjudicated errata in the sec area. If you crunch the numbers a little bit, about 60% of those are actually from open working groups. So the other 40% obviously is from work that no longer kind of has a home. So it's a little harder to deal with. So what we would do is we'd ask those participating in those working groups, and specifically those chairs, to help us out a little bit and adjudicate those 153 reports. Folks take the time from the community to let us know where we may have gotten it a little bit wrong, and let's make sure we figure out whether that's right. And maybe with document updates, we can get those fixed in line, or with the new Errata overlay tool, those changes will actually appear. All right, we have a couple thank yous that we want to have. So first, this is a different kind of hybrid meeting. We've previously had meetings where there are remote kind of participants, but they are not an overwhelming majority. The demographics were that almost 2/3 of SEC was remote and only 1/3 was on site. And this created a very odd situation where potentially there are all sorts of folks in the room, but all the chairs are remote. This was kind of a new thing for us, so we really wanted to make sure that we had backups. So a big thank you to the different SEC working group chairs that pulled double duty in addition to having their own kind of working groups. These chairs kind of stepped in to be an extra set of hands for those chairs that in those working groups that were going to be all remote. So thank you for being our backup. Thank you for kind of pushing the buttons and really making sure that we had a seamless kind of experience as we roll into probably having a lot more folks on site in these exciting in-person meetings. Another really big thank you is to our SecDir reviewers and Tiro for running the SecDir for us. These the reviews done in the working groups as early review in absolutely an IETF last call and as we prep for the telechat are invaluable. They catch so many issues before the documents are kind of published, and kind of as an AD, Ben and I, and I'm sure Paul will really rely on this to help us kind of bootstrap our reviews, especially when things may need a lot of attention before it kind of gets to us. So really, thank you for your service. This is a huge help for us. So the last thank you we really kind of wanted to make here is to thank Ben. Ben has served 2 terms back to back. So, kind of for those that may not be familiar, that's 4 years of his life where, in addition to whatever else he has kind of going on, he is focused on making the security area work for us. One of the things that I've learned about the AD role is that you really turn it into what you want it to be. It's what you invest in it. And Ben has been amazingly generous with his time and expertise. And, kind of personally here, I probably learned as much about the protocol innards from the weekly syncs we have to talk about what's happening as I did from actually reading the documents. So really thank you for that, Ben. If you published a document in the last 4 years, you probably also know that Ben has redefined or really next leveled what it means to get a detailed security review. His diligence has prevented so many protocols from shipping with issues. I was kind of curious. So what's a lot of protocols? What did Ben really catch? So these aren't stats that are easy to kind of get. There's no interface for that. But Ben, I don't know what you think your key was, but I got the numbers pulled. So you balloted on 702 documents during the review, and of those, you dropped 299 discusses. So in recognition of you really saving the internet that many times, we want to help you decorate. So yeah, Ben's video is back. That's good. So I don't know whether folks can see what's behind Ben. So for a long time during COVID, I was looking at a blank wall. And then we had a meeting. I'm like, what is that blue box that you have behind your head? So to clarify for folks that can't see it, that's a really nice blueprint schematic of the Millennium Falcon. So saving the internet is probably equivalent to Han and Luke saving the galaxy from the Empire. So it really feels like Ben, Han, and Luke need equal recognition. So as a result of that, it seems like it should be fair play. So what we have for you is, hopefully you can kind of see that, is a Medal of Yavin to hang next to your Millennium Falcon. So they can be kind of side by side so your wall is a little less blank. And there will be, we'll get that kind of, it would have been more dramatic to give you that kind of in person. We could have maybe had a tall Chewbacca kind of with you. Instead, I'll make sure that gets shipped to you. There'll be a plaque inside. It turns out you can't get things engraved with the latest stats from the telechat from the meeting anytime soon. So that's 2 days away in shipping is what I'm told. But, in all seriousness, on behalf of the community, Ben, thank you so much for your leadership. You helped us get the work started. You made sure we were on the right track, and then you didn't let us ship without, frankly, checking our work. So really much appreciated, Ben. Thank you.
Thank you. And that's really a great choice of a gift with that medal there. You put a lot of thought into that, so that'll be really fun to have on my wall.
Yeah, maybe when you come in person next time, you can wear it for us.
Yeah. Maybe just a SAG.
All right.
And yeah, thanks for pulling those numbers too. That's real eye-opening numbers. Although one off from 300, Maybe I should have tried a little harder.
I mean, I think if you would have known, you could have hit it. I am sure that if we pulled up the leaderboard, you would be ahead of all of us.
Thank you again. It's really,
Thank
really
you.
great note.
Thank you for your service, Ben. All right. So in terms of our schedule, that's the front matter that we had administratively prepared. So I'm going to turn it over to Paul, and I'm going to get your slides up. We're going to talk a little bit about IPsec.
Okay, thank you. IPsec, it's always an interesting item. A lot of security people wonder, why is it still there? Others go like, this is the best thing ever. So it's a very dividing topic. But I'll give an introduction, and not that I think I will change people's minds, but maybe some of people will know a little bit better why it's still around. Okay, next slide.
Paul, I'm sorry to interrupt. Could I ask Meet Echo to zoom in on wherever Paul is speaking, because you got up from the table and I don't see the audience. So I assume you're standing in front of the pink box.
I am right on the X. Literally, both of my feet are on the X. I cannot position myself more to the left.
No, I think the camera's not on you. So that's fine. We can, I guess, continue. But if Meet Echo can fix that, that'd probably be super.
Okay.
Thanks. Oh, there we are.
Okay, so as Yoav made clear on a message to the SAAG list, to the IPsec list yesterday, we even spent a lot of time on how to write the acronym IPsec. This is from RFC 4303 that clearly states that IPsec should be written with a capital I, capital P, and no capital S. So thank you, Yoav, for heckling me as the first person a day before the meeting. Note that all the RFC numbers and drafts that are listed in this presentation, they are clickable. For some reason, they don't always show up in blue because of technology, but you can click on them. So next slide. Some people might remember RFC 6071. It was a nice overview of all the RFCs related to IPsec and IKE. Unfortunately, it's really outdated, even though it still provides a nice overview and 63 pages of references. It is a bit out of date, so it would maybe be nice to do a new one for this, but that would be a challenge to do. Next slide. Another work that's actually a really good read, and I say this obviously because I'm one of the authors of it, is NIST SP 877 Ref 1, Guide to IPsec VPNs. The document was originally about 20 years old. We redid it about 2 years ago. Some of the IETFers in the room have contributed to this document or are authors of the document. It goes to a little bit more detail. So I'm going to just briefly take off my mask because it's hard to keep talking and breathing through it. It includes various deployments and other useful information configurations for various known implementations. It also has a lot of configurations for the NIST and FIPS recommendations. So if you want to immediately be FIPS certified, you can read through it, and it will give you all the guidance there as well. As I say, it's a steal at only 149 pages. I hope you have as much fun reading it as my laptop had swapping Microsoft Word and going through all the revisions over the course of about a year. So next slide. So the problem with IPsec is that it's actually a really, really powerful tool, and you can do everything with it. And as with Swiss Army knives, anyone who owns one has cut themselves with it, probably more than once. So it can do a lot of things. It is complicated, but it is possible to only just use that one favorite tool you have in there. You don't need to use all of these, tools. You can just use the knife, or you can just only use the screwdriver. So you pick what you want, and don't worry too much about all the other things that are there. Modern software comes with fairly good defaults, so configuration should be fairly minimal. And so don't be too daunted by your big tool. You can use it pretty easily. Next slide. So one tricky thing is that what's quite different from other things, such as TLS, is that IPsec consists of kind of two protocols. One is the control channel, which is the Internet Key Exchange that is used to negotiate everything. And of course, it has to be done securely. So it itself is also using a whole crypto set. So it will do an encrypted session, and then once it has an encrypted session, it will then be able to actually negotiate the IPsec and create the actual data plane where the packet encryption is configured usually in the kernel. There are different protocols for doing that. There's encapsulated security payload, which is the one you would be using, which is just the sort of the standard packet encryption. There used to be, or technically still is, authenticated header, which is the non-encryption one, mostly due to 25 years ago export regulations, limited CPU powers of doing things. If you really need something like that these days, you can use null encryption with ESP. So we've really tried to remove it to at least somewhat simplify the whole IPsec suite. Then there's the communication, because this is a two-step process. You've got the user land configuring things to the kernel. You need a protocol to talk in between there. So a PF key is the sort of standard old one that has been used, and that's still in use with a lot of machines, such as the BSDs. Linux had to do its own thing, so there's Linux Netlink that's using a different protocol. You can read up on the RFCs, but you probably don't have to worry about it. Next slide. Briefly already talked about this. So the IKE protocol establishes the state and authenticates and authorizes the peer, and then it will negotiate IPsec. Just to avoid some confusion, when you send an IKE packet and you get a reply back, that's what they call an exchange. So it's not like exchange is sort of a word that's being used in different ways with different protocols. But for IKE, it really means a request and a response that go together. Next slide. Some other confusing terminology, and this is really because things are like 30 years old. And so things have changed, and without dragging up too much mud and old things from the past, be aware that some terms are used interchangeably depending on the year of the documentation was published. So while I prefer personally to talk about IKE SA, SA stands for Security Association, and it's basically the state with all the information in there. I personally use IKE SA and IPsec SA. If I formally, according to the IKE v2 spec, would be talking, I would only be talking about parent SA and child SA. I find that personally more confusing to people, so I use IKE SA and IPsec SA. Next slide. So what does IPsec provide? Roughly speaking, there's like three things you can do with it. You can do a host-to-host encryption, where it's only really one host to one host. It has some advantages that you don't have to encrypt everything, including a full IP header. There's network-to-network encryption, and that can be like various. You can have multiple networks to multiple networks. You can have 0/0 as your network. This is like the tool that is these days used everywhere to hook up things together. For instance, I have IP addresses in Holland. I live in Canada. I use IPsec to tunnel some of those securely to my home, so I have more than one IP address. My visitors don't like it as much because Google appears in Dutch, but otherwise it works really well and secure. Other people use it for connecting hypervisors, making sure that there's a multi-tenant isolation, VXLAN encryptions, tunneling BGP over GRE over an IPsec tunnel. Like, it is really sort of a secure Ethernet cable that you can stick in there, and you can tie it down as much as you want. Some people tie it down a lot with the policies, and you can be very specific. Others use it more as a virtual interface, meaning that if the packet hits the interface, then it must be part of the policy and you send it unencrypted. The fourth key point, encrypt the entire internet by default, that was sort of a goal set out 25 years ago. Didn't really make it happen. So I bow down to TLS and Let's Encrypt and Acme for actually mostly getting that done. Good job. I wish we could have done it. Next slide. So getting down to the core RFC 4303, encapsulated security payload is sort of the core of the IPsec packets. It is protocol number 50, and I say they are not port 50 because that is probably the most heard support question when people can't get it to work, because they see the number 50, they just assume it's like UDP 50 or TCP 50. They don't understand that ESP is a different protocol, because most non-IETF humans have only heard of like UDP, TCP, and ICMP, and they don't know about anything else. So that is, in practice, is a bit of a problem. I'll get back to that later. So what is a packet like that look like? It's a fairly standard, like it's similar to how TLS encrypts things. It's similar to how other encryption protocols work, because it's actually mostly the property of the cryptography. There's some identifying nonces to detect which tunnels. If you have more than one IPsec connection, you want to be able to distinguish them. So the spies are there. You see that there's some algorithm agility options in the packets. We can now do AAD that we couldn't do initially. There's replay protection via sequence number. So even though you can see encrypted packets, you can't replay them and make something happen. There's traffic selectors in them that can sort of dictate policy for which packets are allowed to go in and out. And you can do padding. You can send obfuscation packets that are basically like empty packets, just to make it harder for an observer to figure out what's exactly going on. It supports compression. It's a really complicated story. I really don't want to get into right now. But in general, you're just better off not trying. You can also do very high speed things. The limiting factor on the protocol used to be the sequence number, but with extended sequence number, we basically just display the last bits and we remember the higher bits and don't send them over the wire. But we make them part of the calculation of the crypto and the signature checks. So you can actually reach like 100 gig or more per second speeds. There are some practical problems, but the protocol allows it. So next slide. Uh-oh, I think I lost my first viewer. Oh, there we go. So I just put it on here just for sort of completeness sake. I don't really want to go into too much detail, but next slide. So there's kind of two modes. There's transport mode and tunnel mode. And transport mode is really used for the host to host, and it has less overhead. It doesn't. It reuses part of the IP header and protects the parts of the IP header that can be protected, that don't change between hops. And the good thing is that there's less overhead, so you get more of your original MTU. It generally is faster to look up, because like a kernel only has to look up the source destination IP address. It doesn't have to match up any other policies because it can only be host to host. So the encryption policy and where you send the packets to or where you receive the packets on are the same IP addresses. And of course, this completely fails with NAT. As soon as NAT happens, then things get rewritten. There's various clever hacks to make it work anyway. That's how sort of Microsoft kept L2P with IPsec and transport mode through NAT working. And when I say sort of working, you can see at the last line there, there's what you end up is an IP packet into a PPP packet, into an L2P packet, into an ESP packet, into a UDP packet. And that's just what you're doing yourself. Then your ISP is probably doing something like PPPoE. So this is pretty terrible. An MTU of the inner packet there usually has to be set to something like 1200 to even have a chance to make it over the internet. And then there's, of course, issues because you're using sort of the pre-netted IP address, you get issues on the server where the server has like multiple connections to the same pre-net IP address to different entities. So now it needs to do more complicated state to separate these. So long story short, transport mode is great for host-host encryption in your data center, where you control everything in your own cloud, where you can do this. As soon as you like sort of go through an administrative boundary where there's something like NAT involved, you're better off just not using transport mode. Next slide. So tunnel mode is conceptually a little easier. You just have a packet that you want to encrypt, so you encrypt it and then you stuff it into another packet. It's like conceptually it's much easier. Of course, the problem is that there's a whole new IP header because you create a whole new packet, so you lose a little bit more MTU. Now you need to be careful with policies because if the inner packet, for instance, has let's say 8888 as a source address, you don't really want to reply to Google DNS with your answer. So you have to be sure to understand what it is that you're receiving and sending, and making sure that those policies match what you actually have negotiated and what is allowed to be transported in the tunnel. But the good thing is that you can have sort of arbitrary CIDRs that can go through the tunnel. There's still an issue that ESP doesn't really transfer over the internet. So what usually happens is that it gets stuffed into a UDP packet, and the outer packet doesn't really matter because you just look at the crypto from the inside encrypted packet anyway. So it doesn't matter, it gets rewritten by NAT routers, and you can just sort of decapsulate it later in the kernel. Next slide. So encapsulating USB packets, like I said, there's a bunch of RFCs. Initially, we were doing ESP and UDP. That worked quite well. There were some issues early on in the days with NAT routers trying to be helpful. They sort of tried to be too helpful, sort of screwed our original IKE port, which is on 500. So the protocol switched to port 4500 to avoid these helpful assistants. And so that is usually still in use to transport IPsec over the internet. So it's encapsulated over port 4500. The disadvantage, of course, is that it's very easily blocked. If you block port 4500, then there's no IPsec coming out of your network. You could use a different port. In my experience, at least before the onset of QUIC, is that almost all UDP, if you go to a hotel or if you go to a coffee shop, you have a good chance that all UDP except DNS is blocked, and a DNS UDP is redirected to the local server. And so your best bet is to actually get TCP out, and that's also what other vendors found. So there was some non-standard ways of doing TCP encapsulation of IPsec. Of course, remember, this is a terrible idea because if your inside connection is a TCP connection and your outside connection is a TCP connection, and there's some kind of packet loss happening, then you have like two TCP layers fighting each other over how to retransmit and what to do. So it's really a last-ditch effort to get your packets out. And so there's actually quite some talk about how to best do this, and that's in RFC 8229. That talks about how to do encapsulation with TCP and how to continuously try to move back to UDP because it's just so much better because you don't run into all these issues. There was some interesting thing. Of course, at IETF, we don't advertise people break administrative boundaries. So there's a bit of talk about if someone accidentally happens to block, let's say, port 443 or other ports, you could multiplex this. So you could pretend you're a TLS connection. There happens to be a prefix in the TCP encapsulation for IKE and ESP packets, so that you can actually demux it. So you can actually have a server that runs TLS and encapsulated IKE and IPsec packets. It's a bit tricky because like it sort of breaks what we are supposed to do at IETF, but it is sort of a circumvention technique. But we were also seeing that not having this circumvention technique really caused a plethora of non-standardized VPN protocols to be out there. And so we really kind of had to do this. So it's an interesting political maneuvering. Next slide. So how are these policies managed? So inside the kernel, usually it's in the kernel. For embedded devices, obviously you might not have the separation between kernel and user land. I'm speaking more from like a generic OS point of view. But if you look at the policy in the data state that you have, you've got the security policy database and the security association database. The security association database is like the endpoint information. Which crypto keys are you using? Which host do you need to send the packet to? On what port? Which what protocol? And you've got things like counters, sequence numbers to make sure that your crypto is going right. Then the security policy database basically has the list of rules to say, I have a packet, I need to encrypt it. Which policy applies? Who does it go to? Is it the right IP addresses, traffic selectors, and which state to use. These entries are unidirectional, so you've got one for inbound and one for outbound. So if you got like an IPsec connection, you actually have two states in the kernel, one for in and one for out, and same for policy. So next slide. It's probably hard to see, but if you later look at the presentation, or maybe the people online can see it better. This is an example from the Linux output of the SAD entry. This is one entry I just did earlier today, bringing up a VPN from the IETF network to my server in Amsterdam. So it gives you sort of a rough idea of the parameters involved and the state kept. Next slide. And same for the policy. So here you can see the policy database entry for it. You see a third one because in tunnel mode, there's this sort of IP and IP, and the way Linux has done this is with a sort of what they call a forward rule. So you've got inbound and outbound and forward is where you can things can happen to. You can also filter on things there and do other tricks. Next slide. Puppy intermission. I haven't lost anyone. Everyone's still here. I haven't run out of time, so it's all good. So now we've only talked about the sort of the IPsec part. So now we'll talk a little bit more about the IKE part. So next slide. So IKE negotiates all the parameters both for IKE itself and for IPsec. It starts off with a ephemeral Diffie-Hellman exchange. I was quite surprised I've done IPsec IKE longer than TLS. I was quite surprised to find out that TLS wasn't really common to do ephemeral Diffie-Hellman exchange and have perfect order secrecy inside, and that there were static keys on TLS servers that were used. I was shocked when I found it out first. I was like really surprised, but 30 years ago, IPsec already did this. Like, why is this still happening? Very surprised. Anyway, so after Diffie-Hellman, there's a peer authentication and there's authorization as well. Usually that's X509, could be based on made-up strings for IDs in combination with a pre-shared key. Could be an EAP method. There's various ways of doing that. And once that's done, you can then negotiate one or more IPsec connections where you then negotiate the traffic selectors like source destination between the two networks. Then you've all have to keep this alive. Usually that involves things like make sure that if you're behind net, you send net keep alive, because on busy gateways with telcos, if you don't send packets or receive packets for 20 seconds, your net mappings vanish. And so if you're doing encapsulation over a port and you need to keep that port open. There's also rekeying happening after a while when you've sent too many packets or when you spend too much time using the same key. You want to change over your keys to provide perfect forward secrecy. So there's all this kind of maintenance layer in addition to the initial provisioning that happens in the IKE protocol. So next slide. So originally, 1998, RFC 2409, I think the author's in the room. Yes, the editor author is in the room. Thank you very much. And I really want to say that even though I've been making moves to make this historic, it is still secure. It hasn't really been broken. There have been some weak configurations. There have been implementation problems where the complexity has led to code mistakes and buffer overflows and compromises. But the core of the protocol is still so good that we really had a hard time moving people from IETF1 to IETF2. Like, and to this day, people are still happily running IETF1, and as long as they have like AES and SHA-1 even, as long as they don't use a Diffie-Hellman group that's like less than 2048, it's actually still pretty good. Like, there are some things where, you know, we've improved on the years, but it's actually a really pretty solid document. There's been no cryptographic attacks that broke it or anything. So in that sense, even though people don't like to hear it, I feel that it's been more stable and secure than TLS, which has seen a number of attacks that like are so fundamental that they really had to quickly kill the old TLS versions. Next slide. So there are many extensions. The net reversal was one. Dead peer detection was another one that was mostly needed also because of interference with net routers. There were new algorithms. There were more configuration happening. DNS, Windows, Net BIOS, other things were added. Mode CFG was added to also configure and do multiple things. Additional authentication. All of these things added also multiple round trips, also on a model that didn't really do retransmits very right. So what happens was that both sides would start ending up retransmitting. It would very much complicate the state machine in our code. The implementation I'm working on, the IETF2 state machine, is actually much nicer than the IETF1 state machine. And again, it's not because IETF1 is bad, it's just that it had some different design goals. One interesting one is that it's, for instance, IETF1 is more secure against quantum computer attacks than IETF2, but it came at a hefty price, namely that if you somehow did the authentication wrong, you would just get encrypted gobbledygook you couldn't read, so you couldn't get proper nice error messages. So it's all been like different considerations, putting the weight somewhere else. It's not that IETF1's actually broken. Next slide. One issue was amplification attacks and DOS attacks. Because of the retransmit not being strictly done by only one side, they would go to both ways. Also, there's a DOS attack where you can trigger more packets than more than one packet in a reply. Sometimes that's implementation. For instance, at some point I noticed that for 1 year, one IP address on the internet every 30 seconds sent me an IKE packet, and it was because I once sent them one packet. Although that's obviously not a protocol error, but an implementation error. But DOS attacks is an important thing to fix. There were many modes that also confused people: main mode, aggressive mode, revised mode, hybrid mode. Revised and hybrid were not really used, but main mode and aggressive mode was. Main mode is more round trips, but protects more identity information against passive attackers. Aggressive mode basically said, like, well, we prefer less round trips to set up the connection, but we'll kind of leak the identity of the peer in the clear. It's probably okay anyway, because if you're connecting to a VPN server, most likely that is a well-known server with a DNS entry on a well-known IP address. So it wasn't considered that important. But the problem with aggressive mode was that the crypto was slightly different, and it was actually possible to do offline dictionary attacks if you're using pre-shared keys and you were using a really weak one. So that has been the biggest problem of IETF1, and it's again, it's the humans configuring it badly. It's not that much the protocol, even though, like, you know, maybe we should be aware that we should make protocols strong enough to protect against weak humans. The extensions as well for XAuth and mode config that were very popular took many round trips. So that slowed things down a bit as well. If you wanted to do many tunnels, so many different IP addresses, you'd have to set up one Ibsec tunnel for each one of them. That at some point also runs into scaling issues. And one I found in our own implementation at the time was that not all the fields in an IKE packet are actually integrity protected. So you've got things like vendor IDs that you could actually, that they weren't part of the signature of all the data. And so you could actually modify them and do maybe weird things. The reason we found it out is because the software I was working on at the time tried to be clever to putting a vendor ID payload in that basically said, we can do IETF2. Why did you talk IETF1 to us? And we thought we were really clever to prevent a downgrade attack, but the attacker could just strip it out because it wasn't actually part of the signature. So there was actually no way to prevent a downgrade attack, unfortunately. So if you're migrating, it's better to be aware of this and try to do it quickly. Next slide. So IETF2 improvements. So one thing that was kind of neat about IETF1 was that you could start your IKE protocol, you could negotiate IPsec assays, and then you could tear down the IKE state. Like, you don't need it anymore. The IPsec state is there, and by the time your IPsec assays are about to expire, then you could re-trigger and do a new IKE negotiation and bring up that state. That worked really well until we had to do things like dead peer detection, because at that point you always needed to have that IKE assay information there, because you needed to send like a, hey, are you still there? Yes, I'm still here. And for that, you needed that crypto state that was part of the IKE assay. So in practice, you couldn't really work anymore without that. So in IETF2, if the IKE assay vanishes, it basically takes down all of its IPsec assay children as well. So it's one bundle that you have to keep there. Retransmitter fix, only the initiator retransmits. So the responder just sends an answer, and it's all the responsibility of the initiator. That avoids a lot of race conditions. There was some anti-DDoS protection added. So if you're seeing too many connections, you could send cookies, and if they don't come back with the right cookie, then you can sort of ignore them. They even extended that to puzzles, which is sort of a proof of work kind of thing, where you even put more CPU usage on a client before they're allowed to connect. So there's some good protection mechanisms there. Another important one is that the round trips were reduced by combining the establishment of the IKE assay with the first IPsec assay. So you can sort of do a few things in a somewhat faster way, so you don't have to have as many round trips before you get your first IPsec assay going. Support for EAP was added. EAP it's interesting because, for instance, one of the most popular modes of EAP authentication with IKE and IPsec is EAP TLS, which basically means you're running a TLS connection inside your IKE connection to sort of to your EAP backend to authenticate. That's a lot of round trips, like 8 or more. And so for instance, if you're using Microsoft Windows, you can use EAP TLS for your VPN tunnel, and then you don't need administrative access on your machine. But if you're using straight certificates, it's considered a host or machine property, and then you need administrative access to get that. So while you could do the exact same thing with just simple certificates, without administrative access, you suddenly have to use EAP TLS, and you're like 8 to 10 round trips further down before you have your IPsec tunnel up. So not as nice, but anyway, the support is there. If you can avoid EAP, I would avoid EAP personally. There's the combination of many traffic selectors on, so you can have like a lot of traffic selectors, so that if you have many subnets, you don't have to set up an IPsec tunnel for each subnet. You can just set one of them up for all the subnets. So next slide. So IETF2, there's some evolution through some documents that I've listed there. Sort of the modes, like the main aggressive modes, sort of went away, but we've slowly been adding exchanges to do things like post-quantum and other things. But the basic mode is there's one exchange, IKE assay init, that does the Diffie-Hellman. Then there's one exchange that does the auth, and which also has enough information for establishing the IPsec assay. If you want more different IPsec assays, you can use the create child assay to establish more. And there's an informational exchange for doing various management things, that peer detection, mobile mobility updates, deletes. Those are all additions in IETF1. They're all sort of part of the core spec in IETF2. Next slide. So some interesting extensions. MobIKE, mobility and multi-home. Basically, you can set up an IKE connection with an IPsec connection, and you can probe from a second interface. So for instance, you've got a phone that has 2 interfaces. You can use the second interface to send an informational packet to the other end saying, hey, by the way, it could also be that you're going to send packets to this IP address here. And this is an authenticated way. So it's not just looking at the last IP address that you received the packet from and replying to it. It's actually an authenticated way of saying, I have different IP addresses that I can send and receive these packets on. So if my Wi-Fi link goes down, let's go use my LTE link. The session resumption, obviously also to sort of help mostly the phone case use with your phone goes to sleep, it wakes up, you can do session resumption. Various algorithm updates, poly cha-cha algorithms were added, kind of modern things. ASGCM was already added to Ipsec, but not to IKV1. It was added to IKV2. IKE fragmentation support, there was sort of a non-standard way in IKV1 of doing that. It's been standardized in IKV2 in a much nicer way. So the IKV1 version, if you got one corrupted fragment, you sort of screwed with all of them. You have to get all of them back. IKV2 has a nicer way where you sort of authenticate the fragments by themselves. So if you're missing one, then you can just get the one back. So it's harder to do a denial of service by just making sure you will always get one fragment, bogus fragment sent to before the real one. There's the intermediate exchange. This is to support post-quantum key blobs that are really big, so they don't fit in one UDP packet back and forth. So this intermediate exchange is sort of a chain of events that can happen in between the IKSA init and the IKE auth process to sort of get that infrastructure in place for post-quantum algorithms. There's post-quantum pre-shared keys. That was the one item that said IKV1 is more secure with than IKV2. So it's been added as an extension to IKV2, so you can still add that. There's a multiple KE draft, which is, I guess IETF has to decide whether they call it hybrid or composite key exchange, but it's basically doing your classical key exchange with your classical algorithms and also doing a quantum one and making sure that you can test your quantum one while not degrading the security of your classic one. So that work is also happening in TLS and other places. And next slide. So it might have seen that everything I said was pretty complicated and you want to run away screaming. Let me just remind you, this is my client configuration for Ibsec on my laptop. You can just see, left pick up any IP address, left certificate is my XO9 certificate. I'm saying give me everything you got for left subnet and right subnet. So for the local and remote subnets, you see narrowing is yes, so let the server narrow me down. So the server will narrow the selectors down to one IP address, and that is like, my DHCP obtained IP address that I then use. And next slide. So this is the server side of that same configuration, more or less the same. It just specifies the IDs, the IP addresses, and it has like a right address pool where it hands me a random, like an IP address from a pool instead. Gives me DNS servers, gives me domain names, and I guess I'm terminated. Now, to be fair, there was only one slide left.
I'm sorry, something hiccuped. I lost everything and it just reconnected me. Let me get the slide back up.
I mean, I spent a lot of work on that last slide. Okay, so if you're not sleeping, I'm open for questions, suggestions, comments, criticism, tomatoes, and historic fun facts, because there's a lot of people here that have been here 30 years in a room that might have interesting anecdotes. Yes, this is my puppy. Okay, thank you.
Thank you, Paul. So we are now in the other business portion. So if anyone wants to come up to the mic to say something, please, now's the time. Barry?
This is Barry Lieba. Well, since nobody else has anything substantive to say, I want to just say something about Ben. When I was on the IESG with Ben, we had a IESG retreat where Alyssa came up with this game that we played where everybody gave the secretariat some fun facts about themselves. And we did a little mixer where you tried to figure out which fact went with which person. And that was where I learned that Ben is one of the most interesting people I have ever met. So if the next time you see him in person, start asking him about things like when he worked as a blacksmith and stuff like that. That just fascinating. Get to know him.
I do remember that mixer event. It was very, very fun. I think we had like a bingo card almost of different facts, and we had to figure out who it was from.
Stuart, I see you in the queue.
Good morning, all. Normally, I wouldn't ask such a noob question, but since we just had that overview from Paul, I've not been able to find explicit documentation in any RFC about the bound end-to-end tunnel mode, the beat mode, and I wonder if you could provide a pointer.
Yeah, there is a beat mode, and there's also something called like a wrapped ESP mode. And so there are a few experiments that were done that weren't very successful and haven't really seen much deployment. Although I think there's some interest in doing something with beat again, but Tero is giving a more complete answer.
Tero Kivinen. So beat mode was one of those that were actually done part of in HIP also, because HIP was using actually ESP also. And there was this, it's actually expired internet drafts. I don't think it actually went very well. There was some interest, I think 2 or 3 years ago. Somebody was wanting to resurrect it and move it back. The basic idea there is it's a transport mode payloads in tunnel model semantics. So you recreate the tunnel, you send a packet without the tunnel, putting the separate IP header inside, but you recreate the IP header from the outside and from the policy. So instead of taking the IP addresses outside, the outer IP addresses and putting them, you throw them away, the outer IP addresses, put in IP addresses from the policy, and recreate the new IP header and send out. So it actually compresses things. You don't have to send extra IP header and so on. So that was the main idea there.
Okay, so all there really is the expired draft, right?
Yeah, there's only the expired draft, and I think there's actually a couple of versions of that, because I think it had expired a couple of times. I didn't get the new names. But I think if you just search for beat, I think you can find some of the drafts.
Thank you.
Robin, you're on the queue, top of the queue.
Thanks, Roman. Is the audio okay? Good, thank you. Yeah, this is just a general observation, thinking back, so Robin Wilton from the Internet Society, not speaking for the Internet Society. Looking back over this IETF and the previous one, I think a really interesting development has been the emergence of these kind of oblivious protocols, where essentially the general model has been to take an existing two-party protocol and insert an intermediary node that can perform I don't know if this is a verb, but an obliviating function between the two. And I mean, so Oblivious DO is one, OHI is another one that we've been talking about this week. So in principle, it sounds simple. I know that certainly in the DO case, it gave rise to some animated discussion of pros and cons. And the same thing happened with OHI yesterday. Good arguments on both sides for why people were holding a particular view. And thinking of the OHI discussion yesterday, it struck me that maybe we could analyze those differences in opinion by looking at the trust model in a fairly generic way. So just to make it slightly less abstract, in the OHI model, you have a client trying to reach a target, and you put a proxy in the middle so that the proxy strips out the client identifier so that the target doesn't know who the requests are coming from as a privacy preserving move. But as a result, this intermediate mode is trusted by the client to do one set of things and trusted by the target to do a somewhat different set of things. And if either of those trust models is bent or abused, you kind of break the model. And that was, I think, at the heart of a lot of the discussion yesterday. So I just wondered if, looking at this general pattern of obliviating nodes, whether there would be some benefit in looking at them across multiple instances. So looking at the DOE model and the OHI model and so on, with that through that lens of who is trusting whom to do what, and seeing if that tells us anything generic about this principle of putting an obliviating intermediary into a two-party protocol.
Yeah, I mean, there's definitely an abstract principle there, and Ben noted that I think PPM might be another one to add to that list.
Terrific. Yeah, thank you. I hadn't picked that one up. That would be useful. Thanks.
Yeah, and to add a little further, we have a lot of experience designing and thinking about two-party protocols, but I think once we get into three parties, it's a little bit more uncharted territory for what we've done in the IETF. So,
yeah,
interesting questions, but perhaps not straightforward answers.
No,
worth pursuing.
and that was partly what struck me was there are really good arguments on both sides in many of those instances, and I was trying to figure out a way of teasing them apart. I see also in the chat, Russ has maybe suggested floating this in the T model group, which is another good idea. Thank you, Russ.
Yeah, I think the previous, like the OHI discussions, there may be some implicit assumptions being made that would benefit from being made explicit to help identify why people are so strongly holding the different positions.
Yeah.
Donald, you're at top of the queue.
Yeah, I just wanted to mention that there are things just like that in the non-networked world. For example, there are Freedom of Information Act queries you can make to government agencies, at least in the United States. And the agencies keep a record of everybody who's made such a query. And I guess the information has been returned to them. So there are companies whose business is to accept such requests and then forward them to the government agency. So all the government agencies' records say is there were a whole bunch of these Freedom of Information Act requests for various kinds of information, and they all came from Freedom of Information Incorporated, which will refuse to say what the actual client was that asked them to make the query. So it's sort of an interesting non-network case like that.
Yeah, and a direct parallel with part of the OHI discussion, which was about essentially abusing the protocol to DOS the target, say. And in the freedom of information use case, that would essentially be the equivalent of what I think is called a vexatious inquiry, where you just deluge the government agency with one inquiry after another, and it's essentially a real world DOS attack.
Well, the general solution to that in the real world like that is the agency goes to the court and gets some sort of injunction against it on the ground that it's an abusive process, which is
right. But if the inquiries are going through a clearinghouse, like you say, the agency may not know who to take to court.
Well, they can, in this case, they can order the clearinghouse to stop making the inquiries.
Right, and again, direct parallel with the OHI case.
Yeah.
What is the target entitled to tell the proxy to do if it thinks that one of the proxy's clients is misbehaving?
Yeah,
Network.
as a venue observation, we can continue to use SAG to discuss that, and Model T might be also another place to take that. Okay, other folks that want to step up to the mic line. All right, I'm not seeing anyone. I'm going to ask one more time. No one in person looking at the video feed, and no one in the virtual mic line there. Okay, Paul or Ben, any final words? Okay, in that case, thanks everyone for joining us. Have a good rest of your IETF week, and we'll call a close to SAG. Have a good morning, afternoon, evening. Bye-bye.
I thought I'd introduce myself. Mike Jones. I am one of the active editors in the OF working group, and I'm the cozy.
Yes, I was in cozy.
Yeah, okay.
Yeah, I'll probably reach out with all the working group chairs that are under me and figure out, just have a chat with them.
Great.
What's the official things, what's the unofficial things, get a feel of what's happening, what you might need, what things that Ben might not have gotten to.
There's one IANA registration. And two that I'll come on that.
Okay, yeah, or poke me, like.
Are you official now? Or?
Yes.
Oh, maybe I'll just poke you.
I have the orange up.
Okay. I will poke you. The only reason it's coming up is it's actually from WebAuthn over in W3C. But all the designated experts are authors on the draft. It's a
pretty good stable code point.
IANA, check. Can you approve this? They all have access to it. All right, I'll send that.
Yes.
All right. That's the only.
The risk is more like if people start blocking other paths.
In that case, stepping up, if people block other paths, very aware of the watch it, so there's only a single. Yep.
I'm pretty happy to actually be able to. I'm not sure if they're particularly likely.
But if the proxy, Stephen Farrell tried to talk about that role when he was exiting. And I seriously thought about it because it really matters. But I also knew I have so much active specification and related work that I'm going to get.
So at which point you kind of go, if the target like it really you somehow get 20 hours, then you're already it doesn't matter.
Once upon a time,
Sure, no, but it was, I guess it's more like
publishing research or operating systems.
all of these
Before I started officially.
people might start to say, okay,